Awesome. Okay, so first off, before we get started, this is, as Dr. Mark said earlier on the mechanical part, this is not going to cover everything related to electrical or like give you all of the things that you absolutely have to know. This is to get your mind started on things you're going to have to consider, basically get you start to problem solving and things you need to know and be thinking about when doing your electrical system. So veteran teams, here's what we're going to do. I'm going to go through some stuff very quickly with this and cover the main things that the first year teams are going to need to know, the main areas like that. And then I'm going to do my best to leave a little time at the end and go over that. And first year teams, what you want to be doing, there are notepads right there in front of you. Veteran teams, same thing. If you have any question as we go through this, write it down real quick and say, hey, you may be saying, oh, here, just pass it over to your buddy and make them do it. Whoever's at the end of the row is probably going to be the person asking the question. And what we'll hopefully do is have time at the end to where you can ask some questions. There are experienced coaches, we lost a couple of them, advisors in here that can answer some questions if I can't answer it. I'm actually, the person that's supposed to do this is Michael Sheeb. However, he's not here today for that, so I am the substitute that you get. Either my condolences or whatever. I am from Somerset, Kentucky. I started with Bath County, Kentucky in 2019. In 2019, we had the very first car out of Kentucky to ever race. So I am familiar for first year teams, what you're running into, what you're going to run into like that, the mistakes that we made and stuff like that as well. But what we are wanting you to do is we want you to pass scrutineering the first time. We don't want you to be that part of the statistics that have to come back year after year in order to pass scrutineering. And there are certain things that you need to be made aware of. Dr. Marks covered the mechanical for that. That's one big checkpoint when you go through scrutineering, and electrical is another biggie. They're all just as important, but these are the two areas. If they're going to find something, it's probably going to be in these two areas here. And that and probably, would you say braking is probably the next one? Yeah, braking, which is part of the mechanical as well. So on this right here, please pay attention to what we're going to do. We're going to cover the main components that you need to do and things you need to keep in mind, but this is not an exhaustive by any stretch of the imagination. Powering your solar car. Everybody at this point should have a rough idea that you're going to need solar panels, and we call those PV arrays or photovoltaic arrays. You're going to have things that have to manage the power from that's coming in from your PV array. And or regenerative braking. You can actually get power. We're allowed to use regenerative braking systems, so advisors, be aware if you're not aware of that already. We use that primarily with power trackers, and they have on here DC to DC converters. They have what's called buck and boost systems. Most people, and as they've talked about before, they really recommend that especially for first year teams, you should really be focused on an MPPT is really what we would suggest. When you get further along, then there's more tweaking that you can do. But for first years, getting into that really more complicated and tweaking and fine tuning may be a little more than you want to bite off. Again, that's just a suggestion. Take it for what it's worth. That and $1.50 will get you a Pepsi. So, electric motors and controllers. These are the items we're going to cover real quick. PV arrays, in case you don't know, very quick, sun comes in, hits your solar array, it's going to convert that to power, it's going to go into power trackers, which are then going to control how the power goes into, it's going to monitor both the power that's coming in from your PV array and the power that's in your battery, and then also some of them, depending upon how they're configured, the demand that you're asking as well. That's what that power tracker here is, and generally I'm going to refer to these as MPPT. Some of them, I refer to them as maximum point power trackers because in reality, their purpose is to find out what's that maximum amount that we can get going from one place to the other. Then it goes from there to your motor controller and from your motor controller to your motor. Different types of arrays. The most common type that first year teams are going to use are going to be your standard residential solar panels. You're going to buy the ones that you can get. You get them to where most of the time it's somewhere going to be in the neighborhood of around 62 inches by about 39 inches. And if you stay at about 39 inches in depth, you can get 5 of those in the maximum length that you're allowed, which is 5 meters or 196 3/4 inches, depending upon what you're dealing with. That's going to be where most first year teams are going to go. The downside to the advantage to these is that they have their own structure. They have their own frame, so they're rigid and they're kind of structural. You don't have to build anything or thinking about that. You just have to do something to support that. However, the flip side of that is because they have all that already ready, they're about 50 pounds a piece. approximately. Would you say that's about right? It comes out to about 200 pounds just for those panels. So your first year car, hint, hint, is probably going to be heavy, but that's normal. Don't fret that. The biggest things that we're concerned about with are weight, aerodynamics, electrical efficiency, and rolling resistance. And depending upon which order you put that in, it's probably going to be between you and your advisor on which one's most important to you. But I'm going to tell you right now, in the old days when we had these kind of panels and lead acid batteries, which we'll talk about batteries in a minute, you were already sitting at somewhere around 420 to 440 pounds before you added any frame or structure to your car. So about a third of your initial car, half or a third of your car is going to be just in those two items, and that's it. All right? Here's the cool thing. Batteries, the allowances on that has changed last year, and this is awesome, especially for first-year cars. You're going to be able to do things with your cars that we couldn't do in our first-year cars. Let's see. So you have, go back here. That's one type. Another type is going to be like your flexible or semi-flexible panels. Those are much lighter. They can weigh anywhere from about 4.5 to about 7 pounds a piece, depending upon what their substrates are. The issue with them is the absolute max that I have been able to find on power for flexible panels is about 300 watts, and it won't fit. You still only end up with about, you can only fit about 4 of those, which is about 1,200 watts. Versus something on a rigid panel, you say, well, it's heavier, yes, but you can probably hit somewhere in the neighborhood of around 1,600 watts pretty easy. All right, because you can get a 320 watt panel, 5 of those will fit on there, and you're going to be sitting there at 1,600 watts right there. So it's a significant difference in that. So you have to weigh out the balances. Things you have to consider is like, okay, we're going to get more power over here, but it's going to weigh like 2 to 3 times the weight of this over here that's not giving us much. You're going to have to balance that between that and the weight of your car, how much you're going to need to charge your battery systems, and how much power you're actually going to be using based upon that, your rolling resistance, aerodynamics, and the motors that you're using. You're going to have to take all of those into consideration. And here's something that happens. The first thing that's going to happen when you guys build your car, you're going to build your car and it's not going to have any solar panels on it whatsoever or PV array, and you're going to have batteries in the car, and the first thing you're going to do is you're going to go out there and test it to make sure that it actually moves, and everybody gets crazy excited at this time, the time the car first moves. It's really exciting. And you'll get out there and you tromp it down and the car goes zipping around the parking lot, right? We're assuming all the mechanical's working, right? And you get the assumption, the false assumption, that the car's going to run like this all the time. But you're running off of reserve power in that battery. And the purpose of that PV array, depending upon your perspective, is either to drive your car or to replenish the car that you use from your battery. My personal opinion is the PV array is what we attempt to get our car to run off of, and my battery is a supplemental. The clouds are going to come over and stuff like that. You're going to have to take that into consideration. Weather conditions. Year before last, not last year, I didn't run that race. Year before last, on Monday, it was cloudy and rainy the first day, which means you were running primarily on the battery, or what we considered our reserve power. Your primary power, you're striving, the goal is to get your car to run as much as possible off of the power you're producing from these PV arrays. Would you agree? Because you're not going to be able to at all times. So when you get out there, and it's like, don't deceive yourself going, okay, my car's flying around here, I got all this power. No, you don't. That's reserve, that's backup stuff. The other type, one other type of PV array is going to be, and this is more for, I would not, do what you please, I would not recommend a first-year team going after, and Dr. Marks mentioned the same thing, after doing your own PV array, buying the individual cells and stuff like that. I'm telling you now, I've had teams build 3 different cars so far, and we're not ready yet to do this. We have the cells, no joke, sitting in my lab. There are cells from Maxion sitting there, it's like that. We have the custom battery packs. We're still not ready for it. We started to try that and we realized, oh, we're not there on our experience levels. First year teams, it's a real temptation to do that because you're going, ooh, I have the option. If I go into advanced or cruiser division like that, I can actually custom make all these things. The time allotment for this and the precision and the level of expertise that you need on these is pretty high. Even the Iron Lions, if Mr. Pitts was here, he would tell you, it's taken them, 3 times, I think, to really get this thing rolling. It's a huge learning curve. So just an FYI, those are the 3 main types. We fully expect you to have either a standard residential or some sort of semi-flexible kind of panels for that. That would be normal. I'm not going to go over how much, you guys know in the rules it tells you how much space you have, 5 meters by 1.8 meters wide. That's the area. It comes out to 9 square meters is what it ultimately comes out to. Everybody can read up what your percentages are. First years, you're going to be 22% or less efficiency on the module. That's important thing to stipulate. In the rules it states, and correct me if I'm wrong, anybody with the foundation, it's 22% efficient or less, not 22.01, 22% or less on the module, which means some of these places, in order to sell their product, it's marketing, they will say this is a 23% cell efficiency. You can't use that documentation. You need documentation without permission. You need documentation from them, write them or whatever, and say, what is the module efficiency? Odds are, because when you put these together, they're going to lose power and efficiency like that. The module efficiency is probably, if its cells are 23, it's probably going to be somewhere around 19, 19.7, maybe 20 if you're lucky. For that, they lose a little bit. But you need that documentation in order to pass scrutineering. So just an FYI. Keep that in mind when you're searching for them also. Just because it says 23% efficient or 23 to 25 doesn't mean you can't use it. You just have to make sure, if it says cell, if it says module, you can't use it. Make sure that you go over and use that. And of course, advanced and cruisers, you guys can go as high as you want. Curved cell arrays, how you angle these is entirely up to you. Flexible and the customs are the only ones that are really going to allow you the opportunity to actually mold these around the shapes of your cars. We've already talked about that. These are companies that they talked about in the earlier thing. Mr. Pitts talked about. Raw cells lamination, he talked about that as well. We just mentioned that. If you're going to custom make them, they're going to do this. Contact iron lions who else is, you made some customs, right? Yeah. Yes. Wiley also did some customs as well. I'd contact them if you just want to get into that market.
Tell you all the wrong things to do.
Well, so is that a small thing? No, it's not. Most of the time, what we're going to Dr. Marks was the same way. We're going to tell you all the things that don't work. Why? Because it's a collaboration, not a competition. We're here to get you out there on the track being as good as you are, as best you can be, because by doing that, it challenges the students that we're bringing as well to step their game up. So we share everything. They're bringing their cars. They're going to show you, we'll tell you the ins, outs, what we use, don't use, what's good to use, what not so good to use. That's what this is about. That's the cool part about this whole thing. Laminated cells, we covered that as well. Skip on. This is kind of what it looks like if you're doing this. This is St. Thomas Academy, which by the way has an outstanding solar car program. We haven't seen them in a while, but they're really good. It's very time consuming. We beat this to death. Let's move on. MPPTs and CDC. So you've got your solar array ready. Now that's going to come in. Now the issue with solar, I'm just going to call them solar panels for the moment. For your PV array, ultimately you're trying to get power to your motor. And if you were to try and wire those directly to your motor without anything in between, the powers have to be balanced. The amount, what your motor needs and what's coming in from that has to be balanced. The problem is that anybody that knows anything about solar cells is that when the sun comes up, clouds come over, you do not get a constant power like that. So it's either really high, really low, somewhere in between. And your DC motor does not, your motor controller specifically does not like that at all. They're expecting something in. It's an electronics, like a computer system. So when I first started teaching computer systems, I went into what used to be an old electrical room, was my classroom. And they walked in and said, you got plenty of power in there. We're starting this brand new computer company, but brand new computers in here. And we went in and I had alarms on each of my computers in case the power messed up. And they said, you got tons of power. There's 3-phase all over. And my alarms were constantly going off and they couldn't tell. And I told them, I said, I have the wrong kind of power. It's not consistent. It was up and down and all over the place because in an electrical class, it didn't matter as much. But when you're dealing with electronics, it definitely matters. The margin of error that things can fluctuate on your electronics is very small. All right, very small on up and down. They're very temperamental. So when you're doing this, the key thing here is our MPPTs, our maximum power point trackers. They are designed to watch how much power is in your battery, how much is coming in from your solar array, what your demand is, and to balance that out. They're trying to send it in there so that it's sending it to your motor controller and the request that you have, or to charge your battery, whatever the case may be. It's monitoring all of that and making all of those decisions for you. I will tell you that Mr. Pitts mentioned the Midnight Solar MPPT. That is the one that we use. That's a really good one. That one and the Outback are two really good ones for you to start with. The things like the aerials out of Australia, and what was the one that started with an E? What was the other one? The new one he just mentioned. Elmer, yes, the Elmer. Those, if you have a really good electrical person as a mentor to train you guys like that, you might want to jump into that. But my recommendation is for first years, stay with one of the standard, and those are residential. Those are meant for homes. Those are meant to be mounted on the wall, just like the residential panels. So they are made to work with those. There's no problem. They have all kinds of little add-ons that you can get your telemetry and find out how much information is going in and out. And I'm going to say this right now. This is extremely important. The first year that we built a car, we were so rushed at trying to get the car finished, which a lot of teams are. Start now. I love the fact, Dr. Marks, that you've moved this to this time in the year. This gives everybody an opportunity to get started. We used to do this, didn't get this information until January. This is huge for you because you don't have to be rushed on this particular thing. You can make a lot of decisions with informed decisions now. We did, on our MPPT, we had it was stuck in the back. We didn't have anything connected to it. The only thing we knew, just like Mr. Pitts was saying, was that, okay, we had a little meter that told us what the charge on our battery was. We didn't know. We knew so little at that point that we didn't realize that under load, it wasn't giving us what the actual amount was in our car. So we were driving the car based upon what we saw the voltage of our battery pack was, which wasn't accurate to begin with. We learned after that first year. In the second year, we put in the Whiz-Bang Junior, put the monitors up front, and lo and behold, if we didn't run 10 times better than we did before. Now, we also had a better car the second year, but we actually could use data to our advantage to make race decisions. You need to have that telemetry on there. Try and get your cars finished enough so that you can test them and get your telemetry on there connected to your electrical systems, both your high and your low voltage, so that you can make informed decisions and run the best race that you possibly can.
Brian, can I say one thing?
Please.
We're going to be having a specialized program on telemetry during our November workshop. So if this is so significant, we've got a section blocked out for that early so we can get a chance to find out more about it.
Okay, is that in November or just January?
It's November 5th.
Okay, November. So, yeah, there you go. Dues, max dues for these right here. You will, a lot of these MPPTs, so it'll say like here that you need to adjust the voltage from your array to give the most efficient transfer, adjust the output of your array to the right voltage. It's like this. Here's the nice thing about this. Your MPPTs will automatically recognize your battery pack that you have, the size of it, and as long, and you just go through, there's a couple of little settings you put in, and it will do most of it for you. Now, you can even tweak it a little bit further beyond that. So those who are when we say my intermediate level teams, you go in there, you can get a lot out of those MPPTs. You don't necessarily need to automatically jump to those high-end MPPTs for that in order to get a lot of use out of it. All right? Aerial, these are the ones just like in the pictures. I'm not going to cover these greatly, but again, these are the two that you saw on that Mr. Pitts had. He had all of these same ones on there. I'm going to tell you now that we're bringing, our plan is to bring 1 to 2 cars, potentially 2. We will have the Midnight Solar probably on both cars because it is that efficient. The only downside I find to it is it weighs about 22 pounds roughly, 18 to 20 pounds, something like that. Is the weight. That's the only downside that I find to these. Put them in a cool place. Let's see. So this is the aerial, right? So you can kind of see just from the picture that this is a little more complicated. It's going to take a little more planning and knowledge base in order to implement these correctly on your system so that you don't have a short or some sort of electrical issue. If you go back over here to this right here, literally has, you take the positive and negative from your PV array, they go in, there's a spot you plug them in, you've got a battery positive and negative that comes out, goes to your battery system with your fuses and stuff that we'll talk about, and that's pretty much it. Other than getting your, like you can plug in, it's like an RJ45 jack to get your screen for your Whiz-Bang Junior, get some data. They're pretty easy, and programming them, get with one of us. It's real simple to do this.
Brian, can I say one thing about the picture you showed just a minute ago?
This one?
What this was designed to really show too is that you don't need to put your electrical system into the car before you see it work.
Yes.
Set up your electrical system outside the car. Make sure, I mean, including the turn signals and the horn and the power trackers and all this, and see if it works. Because then if it doesn't, then it's more easy to fix. If you get it into the car and you're sort of blind as to where some of the wiring goes, and I hope you talk about wiring.
I'm going to piggyback off of that statement. I'm going to tell you what we do. We do that, one, to make sure that our electronics and things will fit where they need to. The seat, the clearances are there for the drivers and all of this. We do the frame, we do the roll bar, we do the crush zone, all to scale using PVC. You can heat it and bend it and all this right here. We make a duplicate of what we think. That way, if we don't like it or something doesn't work, we cut it off, fix it, and then, guess what? Once it matches like that, then we can start working on that. But here's the additional advantage of that, and it has to do with the electrical. While they're building the frame, our electrical crew is not stagnant. They can actually start doing their testing and even making wiring harnesses for the car because they have a full-scale model of PVC sitting over here, and they make their wiring harness while the car is being welded together and the things are mechanically going on. So you don't want people just sitting around. They'll run off on you, advisors. They'll leave if they're not busy, right? They will. It's just the way it is. You got to keep them busy. So what we found is it does two things. It makes sure that everything fits, and two, we can identify problems by doing that there, and our electrical teams can start then fitting everything, and literally they make the wiring harness and it's already sealed up and ready, and when the car's ready for that, they literally pick it up, take it over, and install it into the car. There's no running wires or anything like that. They just simply take it over and take it in, which is exactly how the automotive industry works anyway. They have an entire company that makes their wiring harnesses. My brother-in-law just retired from Toyota. They manufacture Camrys like that. That's literally what they do. That wiring harnesses come in, they open them up, spread them out, and slap them in the car. So there's no reason we can't do the same kind of thing. In addition, that goes back to what Dr. Marsh was just saying. You can test it on the bench. Before you stick it in the car and you spend all that time and energy and strapping it in there, you can put it on the bench and test everything and run everything through it. That's both for your high voltage and your low voltage systems. Batteries. Choose carefully. So before this, we used to say that lead acid batteries were the only ones for the Classic, Advanced Classic, and the electric solar, or the two-seater car for that. That's all you could use with lead acid. Boy, I'm telling you what, this is exciting now. I was really excited last year. We didn't come, but I was really excited the fact that we opened up to lithium iron phosphate. Why? Because one of the biggest hindrances we have to our cars, or one of the challenges, I shouldn't say hindrances, but one of the biggest challenges you had in that is that weight issue. And the lead acid batteries are simply just heavy. The other thing is that the lithium batteries, if you don't know this, you can actually go deeper into them. And I'm going to let you research that with your advisors on all the details for that. But what you need to understand is that your lead acid batteries have about this much room to drop from here to here, if this is the bottom, whereas your lithium batteries are going to you can drop a little deeper in them, and they charge and discharge much faster, correct? The only reason I can think of at this point that somebody might want to justify using lead acid simply because they're so heavy is that you may have a financial issue. However, I think that there are other areas where you can save money and get yourself, as you were saying a minute ago on the PV array, get yourself some good cells, get yourself some good batteries. It's going to, that's what's driving your system. Between those two, you're providing power for that. You need to find someplace else. Don't skimp to make it dangerous like that, but do you need to pay to have the nicest graphics on your car? Is that going to affect how well your car does? You kind of get where I'm going on that, right? And I cannot stress it, this is a safety thing on the lithium iron phosphate. So there are three types of typical types of battery packs that we see out there. It could be a lead acid battery, and now we have lithium iron phosphate, and we have lithium ion. Those are the three main ones that you're going to see out there. You're welcome in advanced and cruisers, whatever chemistries are out there, the sky's the limit. If you want to use a gel or whatever, those things are available to you, but those three are the big ones that are out there. In your lithiums, your lithium ion and your lithium iron phosphate, you have a safety issue. The 1 year we were thinking about using some lithium ion batteries, and we decided no, we're not going to do that because if you don't know what you're doing with that, you can get yourself into a risk of them catching on fire, and I mean, and when a lithium battery catches fire, it's not like, oh, just a little like you're going camping or something like that. It's a major deal. If you want to look up, I don't remember what year it is, but the World Solar Challenge, there was a car that caught on fire during the World Solar Challenge, and it was a big carbon fiber, beautiful car, but it caught on fire. They barely got the person out of the car, and in a matter of minutes, I mean minutes, not like 30, 40, but in minutes, it was nothing but dust. I mean, it goes up, it burns quickly, and it burns hot. Here's the cool thing about the lithium iron phosphate. It's pretty stinking stable. All right? So that's what's really cool about it. You get a lot of the benefits that you do with the lithium battery packs and still get the security, as long as, hint, hint, as long as you have a battery management system that is rated for what you're doing. If you buy an off-the-shelf system with a battery management system, you say, and it says it has a BMS, great. You have to monitor that at the cell level, and you need to be able to demonstrate that it's going to do that, have the documentation or whatever the case for that, right? Not all off-the-shelf batteries. We were talking about this earlier. I said I'd address this when we got to it. Somebody was talking. Was you talking about the golf carts? So they have these. You have a 12-volt battery. You can take a 12-volt lithium iron phosphate battery and put it in. Yes, you can. But you guys are going to be running 24, 36, 48 volts or higher on your systems. It has to have a BMS that's not just for the 12-volt battery, but for the entire battery pack voltage that you're going with. If you don't do that, then you are going to have a problem. And it's not going to be pretty. You're probably not going to pass if you don't have the documentation. Well, actually, I can almost say with certainty, you won't pass unless you have the documentation. And what you need to know is, most of your motors that you're going to choose are probably going to be in the 36 to 48 volt range, with the vast majority of them probably going to be 48 volt systems, right? There are only a few companies that I have found so far that make BMSs that allow you to put those batteries in series to 48 volts and the BMS still work. It's not like the lead acids where you can just simply link them up in series or parallel and multiply your voltages or multiply your amps. You cannot necessarily do that. Please do your research. Advisors, do your research with your students. Double check them before you start hooking them up, or you may have a major issue with that. Have I beat that horse to death?
Are you suggesting that if we use 4 12-volt lithium-ion batteries with internal BMSs on each, we would need a 5th BMS?
No. What I'm saying is this. Okay, so Brand X makes a 12-volt lithium iron phosphate battery with BMS in it, right? It's like that. But Brand X says you can't put them in series because their BMS isn't even though each one of them have one, they don't take care of that. They're not rated for the entire battery pack.
PowerSonic batteries?
I'm not going to get into that. You have to look that up, and I'm just saying verify that. There are other batteries. There are some in there, and I would recommend call the company or make sure that it's in writing that says up to 48 volts. Does that make sense? Everybody with me? I'm not telling you what to use or not use. I'm not doing that. I'm just saying be aware that is something you need to be aware of for safety concerns, and you need to double check those. Yes, sir.
Again, not telling you what to do, but I will tell you from our own personal experience, on Brian's point of economics, the best, in my opinion, from our experience of the lead acid was the sun extender batteries. They're very good for lead acid. But if I went and bought a new set of them right now, before shipping, it's going to be $1,600.
Oh, well, then it's no brainer.
I could go buy, and then also speaking from our experience, what we wound up with, and on the front row, if you listen to this, we ended up getting a Signature Solar server rack, 100 amp hour battery, and it was their B2 model. I think they're $1,600 or $1,649, so within $50. It has built-in fire suppression, and that battery, the nice thing is you can go deeper, and those sun extenders, as good as they are, they'll sulfate on you some, and I had to get a new set every year, except the 1 year I was not intelligent enough to realize I needed to. So economics.
Yeah, it's no longer an issue, is it?
It's now cheap enough. Go with one of these server rack ones, or at least I found good
Well,
experience for us.
well, actually, that battery you're talking about, I looked at it just Thursday. I looked at that same battery because we were talking about this before. I looked at that on Thursday. It was actually on sale for $13.99.
There you go.
So which is less. There you go. So hint, hint. Highly recommend lithium iron phosphate. Just make sure your BMS is good.
Then you just go ahead and get one that's 48 volts or 50, nominal,
Yeah.
all in one package. It's got the built-in fire suppression.
You have to decide, one of the things that you have to consider when doing all this is this. So we've been talking about batteries, right? So you just don't randomly go choose a battery. You have to think of your car as an entire system. Everything affects other. So like, how many of you are into gaming? How many of you are into gaming? Yes, play games. Video. I know, oh please, you can't tell me you guys don't play video games. Yeah, right. Okay, so I have a gaming PC. If I'm building a gaming PC or I'm building a computer system like that, one of the things that we had to teach our students was this, is that thing called least common denominator, or the weakest link, right? Your system, on the computer system, I could spend all this money on a bunch of RAM, a great video card, whatever the case may be, and if I don't have X, like maybe I'm doing online betting and my network card is like really, really wimpy, or my video card is really wimpy. One item, I could spend all this money on these great other items. If I spend one, because I don't have any money left on this item right here, guess how fast my system goes? It only goes as fast as that weakest piece I have. You have to think of it as an entire system. This is an entire system, right? So you have to keep in mind, one, the weight of your car, the electrical efficiency, the rolling resistance, the aerodynamics, all of those are going to affect overall your electrical efficiency on here, how you build it, how long you run your wires like that as well. When you're choosing your batteries are going to be dependent upon, one, your motor. What is its demands? How much power can you put back on that? When we were dealing with lead acids before, one of the questions we had to ask ourselves was, I have a battery that's this big and then it's going to drop down. I'm never going to be able to, if I can't charge it all the way back up, do I really want to carry that extra weight that I'm never going to be able to charge back? Some say yes, some say no. I'm not saying good or not like that. But you have to keep in mind that you need to be able to charge your battery with your array as well for that. So you're going to have to balance those things out. What are your needs? What are your power needs? Do you have reserve power, and how much can you produce? All of those things need to be in your decision making while you're choosing your products. You can't just choose one and say, hey, this is a great motor, let's do it. And then you can't produce enough power to run it. That's kind of useless. Does that make sense? How much weight, how heavy is your car going to be? That's going to affect what motor needs are going to do, which in turn is going to affect what kind of battery system you're going to need, which in turn affects how much power production you're going to need for that. It's all a system. Keep in mind that every decision is not isolated. Every decision, there is no decision is on an island. It all links to each other, so keep that in mind. Is it a road race or track race? Believe it or not, that does matter. That's going to matter on, like in the mechanical aspects like that, what kind of suspension you use, what kind of wheels you do. For us, it matters on what's going to happen with our PV arrays and our batteries and our motor systems like that. Because on the track, it's mostly flat, except for turns 2 and 4, I believe. They come up just a little bit. But on a road race, I'm presuming, I haven't been on one, but I'm presuming they have some long gradual hills they have to deal with. Is that correct? Mm-hmm. Yeah, so on those, they're slightly different. So keep in mind that a track race and a road race, the demands are different, and you need to keep that in mind when you're selecting those. Lithium-ion batteries, typically before, what you were, if you're doing, I guess lead acid still 5 kilowatts?
5.25.
But for lead acid, it's still...
It is the 525. It's
Okay.
a 20-hour rating.
Okay. Oh, that's the other thing. See where it says there's a little laser on here? Anyway, trying to see my laser. Oh, there it is. See right here where it says 20-hour discharge rate? When you're doing your battery selections, not all battery companies put these in the 20-hour rate. You may have to either get documentation from them or do the conversions like that. But always have documentation for that, because you can get deceived on that right there. It's all marketing, so they want them to look as good as they can. Remember the solar cells, 23 to 25% cell efficiency? Yeah, that's a selling point, but in reality you don't get that. Make sure that you double check that's a 20-hour discharge rate for that, and you're now allowed 5.25 kilowatts worth of power for that for different divisions. The cruiser division is 10.5 kilowatts, and I believe that's it. That's the only one that's different, isn't it?
The electric solar power is 2.65.
Oh, that's right.
per
The
watt.
electric solar, the one where you change the batteries in and out, is going to be half of that, which is 2.65 per battery, and you have 2 batteries for that one. So if you're doing the 2-seater, there's no solar panels on the car. Now here's a cool thing about this one. We were talking about the panels, right, and the weight of them. This particular car doesn't have panels on the car. So your solar or PV array charging station, it doesn't matter how much it weighs because it's not on the car. But on that one, you only run with half of a battery pack in it, and then you swap those in and out. You got one charging over here on that battery pack, and I will tell you this, that if you decide to go in this division for whatever reason, please keep in mind that electrical system is a third system that you have to keep in mind, because your charging system is over here, sitting over here at basically a gas station type place where you go swapping batteries. Then you have your high voltage drive system on the car, and you have your low voltage system on the car. And you have to make sure that you have all of the same safety aspects, like your emergency shutoffs and like that, at both places, and all of your monitoring, your low voltages and stuff like that as well. So we'll get into that. Any questions so far? Am I going too fast? Not fast enough? This is, you notice down here where it says it weighs about 230 pounds. That's what we were talking about before, that and the other panels. That would be for this weight, this 230, that would be lead acid. I believe that a 5+ kilowatt lithium iron phosphate battery is going to be somewhere around 84 to 86 pounds. I think it's about that. So it ends up a little bit less than half. That's kind of cool. William loves to go into this portion right here.
He does.
I'm sure they're going to do this in January. I'm going to let him go. I'll share this leave this for him. Basically, though, this Pukert number that you have, the closer you can get to 1 on this right here, you'll see the little things right here, the better it is. You'll never get to 1, all right? But the closer you can get to that, the more efficient and the better that particular battery, particular portion is that for you, and it's going to be in your documentation for the batteries. You don't have to turn this one in, but it is handy if you go look at it if you're really into that. As he said, only for lead acid. If you decide, this is for the intermediates and advanced. This would not be a recommendation for the first years, although you might find yourself on a need for this. If you go to make your own lithium iron phosphate battery, or lithium ion, but we're talking about LifePost here. These right here, this would be an off-the-shelf, ready to go, and it's going to have a BMS in it for 12 volts, because that's a 12-volt battery. Up here, you can actually buy these in, I call them blades. They're little boxes about like right here, and you can actually screw them down. The nice thing is there's no welding, unlike lithium-ion batteries where you have to spot weld them to make your battery packs. They look like oversized D batteries, 18650s I believe is what their numbers are. But the lithium iron phosphate come in these little things that look like little boxes, and they like tiny little batteries, and they're 3.2 volts typically each one. And you would put those in line and hook them up in series or in parallel, depending upon what your needs are for your battery and for your motor, like that. And you put them into various things. This is where you would have to buy this one will not, when you buy those little blades for that, don't simply just wire them up and say, hey, I've got a battery ready to go. You need to make sure that you order a battery management system that is rated for what you're doing. Now, you notice I said in parallel and series. That's a reason for that. Your battery management systems, if you go to Amazon or you go to Ali or you go someplace like that and you buy a battery management system to wire into this, needs to know how many P's and how many S's are it. How many are in parallel, how many are in series. And they will be rated for that. They'll be like a P4, S4 or something like that, depending upon how many in parallel and how many are series. So when you figure up your battery system, make sure that you order your battery management system that monitors at the cell level. Each one of those cells, it's going to keep them out and balance them for that. It's going to help you keep you safe and your system running most efficiently. You have to hook that up as well. When you hook up your battery management system, follow the instructions carefully. There are a lot of little leads that come off of this wire, and they have to go in a very specific order on specific cells for it to monitor correctly. All right? If you have questions about that, you get in and you say, hey, we have to do this, but we don't know how to do this, please contact send questions out. Dr. Marks will get that out to appropriate people. We will get you help. Much better to get help, ask a question and get help than it is to have a problem with this right here. It's pretty unforgiving. Testing batteries, know what your batteries can do. All batteries are not made the same. We were literally testing batteries this past week. And these are our testing batteries. They're the batteries we test, and we were testing them to find out. Some of them will, like when you charge them, they have a certain charge when you first do it. You have to let them set and rest, come to a static, what's the word I want? They have to stabilize. They need to stabilize your batteries, and then you check them. And we started checking them, and it's like this one's dead on, this one's dead on. Ooh, this one's low. we want to pull that one out and put another one in. It's much better for your systems if your batteries, when you first set them up, if they're equal for equalization. Now, sometimes you can put them through an equalization process. Your advisors will help you on how to do this if you need to do this. But sometimes you can do that, but you do need to double check them. When it says test your batteries, again, this is the St. Thomas Academy. What they're doing here is they're literally testing every battery. They've got them set up to a series of lights, and they would pop out like that, and they would track. They would sit there and track every one of them and determine how long it took those batteries to actually go from charge all the way down, what the voltages they were getting at each one of those, and then they would try and match the batteries up if they're doing a 48 volt, 4 batteries that are as close to each other as possible, because that makes their system run better. Nice thing about the lithium iron phosphate systems and the battery management is it does a lot of this balancing for you. Actually, it does pretty much all of it. That's the Concord the sun extender. That's what he was talking about a moment ago. Let's see. Electric motors. So now you've got the power coming in. It's going. You have your MPPT, which is balancing that the back and forth to your motor. And then in reality, the next item probably should be your motor controller, because the power is going to go from your battery system into the motor controller, and your motor is going to be run off of that. Your motor controller is what actually makes the request for how many amps it wants to draw from your battery pack or your PV array, and it's going to go to your motor here. There are 2 main types of motors for everybody except for Cruiser and Advanced. So for all of the other divisions, Classic, Advanced Classic, and Electric Solar, you guys have basically 2 types of motors that you can choose, which is either going to be a brushed or a brushless motor. The brushed motors, basically, they have little brushes on them. You can, again, chat with your advisor on what that exactly means like that. We're not going to that at this point. On those, the nice thing is that they're easy to wire. There's simply a positive and negative line on the motor itself, and the motor controller, while I'm getting there, has just a positive and negative for the motor to come in. The brushless is actually going to have 3 to 4, generally 4 wires that come off of that, and it is a different type system, almost a 3-phase kind of system, and it must use also a motor controller. And listen very carefully to what I'm saying here. You have a brushed and brushless motor, you must have the appropriate motor controller for your motor. We have in my shop both brushed and brushless motors. We cannot mix, we cannot swap those motor controllers, right? They're not designed for that. Please make sure when you order these, I think Mr. Pitts mentioned Thunderstruck and Electric Motorsports, things like that. Those are great places to go and kind of like say, I want this, this, and this, and it all puts together a nice little kit for you that's meant to work together for you electrically. You still have to wire everything and know what you're doing, but you know that those pieces are designed for each other. Your motor controller needs to be rated for the motor that you're using and the battery pack that you're doing, whether it be a 24, 36, 48, 72 volt or a 60 volt, whatever you're doing for your motor and what you're expecting to run your system at, your motor controller needs to be rated for that as well as the amperage for that. And I'm going to jump over here as you mentioned before, while we're talking about amperage and voltage like that. Some of your systems, the Mott Energy 0909 motor runs continuously at 100 amps. It can run peak for about 30 seconds at 300 amps. Your wiring needs to be rated for your peak and maybe beyond. He mentioned on there the welding wires like that. Please, I'm not telling you, I'm not going to mention a gauge yet, okay? I'm not going to tell you what gauge. You need to make sure that you choose appropriate gauges for the wiring that you're running. With that in mind, I'm going to mention a low voltage. I'm going to jump over to a low voltage item here. Our horn last year, or year before last, was a problem. We couldn't get it. When we hooked it up next to the battery, it worked just fine, just blared all over the place. We moved it to the front of the car and plugged the wires in. We couldn't hardly get it to go at all. And the reason being is that the wiring, the gauge of the wire from the battery to the horn wasn't heavy enough to carry the load. Your horn, believe it or not, ladies and gentlemen, keep this in mind, it pulls a lot of power. Your turn signals are probably going to be LEDs and stuff like that. Your horn on your low voltage is going to pull a lot of power. Please make sure that the wiring for your horn is rated appropriately. Otherwise, you're going to sit there and go, why doesn't my horn work? And you're going to be chasing like we were all over the car looking for something that was short or disconnected. And in reality, we just had the wrong size wire. All right? Please make sure you choose that. When you choose your motor, brushed or brushless, make sure you choose an appropriate motor controller for that. The brushed is easier to wire, and they're usually less expensive, but they're a little less efficient. When I say a little less efficient, A brushless motor is probably going to be somewhere in the neighborhood of around 85 to 90, if you're lucky, percent on a brushed, and a brushless is probably going to hit 90 plus. Just understand, it's going to, the wire, the cool thing is that when you get them now on the brushless, there's going to be 3 wires on there that are critical. They're color coded typically to your motor controller. So it's not, don't be afraid of it, because it's typically color coded. But you do want to make sure, I will say this, on these, when you get to these, and let me see if that's in the next phase or not before I jump over there. Come on. This is a Briggs & Stratton motor. This is a perm motor. These are your data sheets. You can look them up for that as well, get in specifics. They'll cover a lot of this stuff in greater detail at the next workshops that you have. Hint, hint, come back to the other workshops. This is the 909 motor. I have one of these sitting. They work great. This is a brushed motor. It's basically considered in solar car worlds kind of like the workhorse. It's almost impossible to mess this thing up, and I'm not kidding. It really is kind of a tank. So if you advisors, if you have people that really destroy stuff all the time, this might be a good one. But yes.
There's also a lot of good gears available through different resources.
Yeah. Yeah, I'm going to tell you from firsthand experience. We used, year before last, we built a 2-seater. Came in, and it didn't weigh, it wasn't terribly heavy. I mean, it was probably right at around 800 pounds, I guess, which is probably about the somewhere in that neighborhood, for right weight for that. We ran a new motor that really hadn't been run in the Solar Car Challenge yet before. We ordered they mentioned QS motors. Well, we ordered what was called a mid-drive system out of China. And we figured, okay, well, they're using 2,000 watts in like the advanced cars I got, so we went with a 2,000 watt. It's great on the flats. Any kind of hill, it bogs down and wants to kick out. And Dr. Marks will tell you, we had nothing but trouble for about 2.5 days down there until we finally found Enrique brought us a 3,000 watt motor that fit ours. We had to change it out. And the thing is, when I say mid-drive, that motor's actually in the swing arm of the thing. So you have to pull the swing arm apart, put a new motor in and new motor controller, because our motor controller wasn't rated for the higher 3,000. The last day and a half, it took a half a day. We had to shut down for half a day during the race in order to do all this right here. That last day and a half, we ran fine. So when he's correct, don't underrate that. For the track, you need at least probably, if you're doing this right here, you should be looking at probably about 3,000 watts. You can go crazy and it's going to hurt you, like if you went 8,000 like that. But I can tell you from firsthand experience, the 2,000 watt QS motor is great if you're running on pure flat. But the turns 2 and 4 at the track are even too much for that motor to handle. It simply is underrated. So if you're going to go with that, the 3 works okay, but works better. This is the hub motor, and this would only be for those that are running in advanced or cruiser division. You can use on them. Now, you're welcome to use any of the motors in the advanced and cruiser. You're just probably going to be outclassed unless you're using something along, well, I say that. To be honest, there's some people that have ran pretty well with standard motors, but this is what they're pretty much going for as a hub motor. NGM makes them, Mitsubishi makes them, QS Motor makes them. They're a little pricey. QS Motor is probably the cheapest of all of them. They can be expensive. Motor controllers, we talked about those. I'm not going to go over the brands of those because Mr. Pitts did that. Take a look at his. He has a great list of all the resources like that. You should be scouring that. Okay, so the question was, is there a voltage limit for the low voltage system? The answer to that is no, there is no specific. However, keep in mind that inside the driver compartment has to be 36 or below. Is it still that? Is it? No. So your low voltage system, okay, so he wants to know what the capacity is. There is no limit on that right there. Let me get to that in just a second. I'll explain that. Let me get through this real quick. Gearing, all I'm going to say about gearing is this. Gearing is going to determine how torque and speed are conversely relational to one another, which means if you have more torque, you have less top-end speed. If you have more top-end speed, you get less torque. And you cannot get the best of both of those and raise them both up time. They work opposite of one another. That's simply just the way things work. So what you have to determine is how much power or torque do you need for your car to move it that is most efficient in the use of your electrical system for that there. That's about that's going to be some calculations you got to figure on. It's going to be dependent upon your car, its weight, its rolling resistance, its aerodynamics, what the terrain is, whether it's torques like that as well. There is no reason for classic, advanced class, well, you're not going to be running 50 miles an hour. Remember, this is not, as Dr. Mark said on many times, this is not a speed race. This is an endurance race, all right? So this is not a matter of how fast you can get to the finish line, but how many times you can go by the finish line, right? You're trying to get as many laps as you possibly can on a closed course race. So there is a sweet spot for your car. In general, we have found that in the classic cars, it's somewhere around 23 miles an hour, give or take, is if you want to talk speeds. That's kind of, for most of the time, that's about the sweet spot for it. It is, however, with the lithium batteries like that, that stuff will probably change a little bit because they'll be able to perform a little bit better as we go. For advanced, I'm not even going to guess how theirs is going because they're like killing it in the advanced division right now. Roz Energy and Iron Lions, they're just, and Covenant, they're just like, they're killing it. They're making it hard for us. Your drive system can be chain driven, belt driven. It can be technically a direct drive, just not a hub motor for that. I say that very loosely. Most of your systems are going to be chain or belt, other than the advanced and cruiser, which can use hub drive systems. Auxiliary, this is where your question comes in. So we talked about first off, before we go into low voltage, and it's just going to be quick, are there any questions about the high voltage components or what you need to consider, this and the other? So the answer to your question is, his question was earlier, is there a limit for the battery system like that you're running for that on the low voltage system? And the answer is no. As a matter of fact, even when they had lead acid battery propulsion requirements for the classic division, you could use lithium ion batteries or lithium iron phosphate batteries in the auxiliary system. The reason being is those two electrical systems are separate from one another. You cannot set them up there with just a couple of minor caveats on like monitoring this stuff like that. You cannot get power. Power from your auxiliary system can't be linked into your propulsion power system. All right, you can't be like, we'll steal a little power over here from this. But the nice thing about that is, the reason it doesn't is that you can have a tiny little, some people even use like the cordless drill batteries. That they hook that in and it sends power out to their stuff, and they just have them charging like plugged in the garage, whatever. And when it goes low, they come in and they say, "Hey, I'm coming in for a battery swap." And when they say battery swap, they're talking low voltage, right? And so they come in and have it come with that. They come up, they come in, they swap the batteries, put them back on, because your low voltage alarm may be going off saying, "Hey, my low voltage battery is down." Why is that important? Because your low voltage system includes all your safety stuff: turn signals, hazard lights, horns, right? Your battery management, it's your safety stuff. They don't want that linked into your drive propulsion, because if something happens with your drive propulsion and it kicks off, not only does that kick off, you may stop, but you have no safety systems on your car in order to tell something to turn on your hazards or your turn signals or anything like that to let them know, and you could be stalled on the track. You've got to flip your hazards on. So they have to be separate entities. So is there a limit on it? No, they do not place a limit on it at all, because they want that one to run all the time. Now, the question you're going to have to ask yourself is, how big of a battery do I need in my low voltage system in order to maybe run in classic, run for half of the day until lunch, and then maybe put that one on the charger, put a new one in during lunch in that right there to run your lights and stuff. Again, we're not talking about your propulsion. That one's sealed. Yeah, so, and we do the lithium because they're lighter, all right? Weight matters. But don't sacrifice in anything we do. Never sacrifice safety for weight or for anything. Safety takes precedence over anything else. That's why we have scrutineering. Scrutineering is to check the cars to make sure that the car is safe and that you can handle the car safely, right? It's all about safety. So don't sacrifice those things, sacrifice safety for any of those items. It's just simply not worth it. You're going to learn and figure it out as we go anyway. I am going to say this. You guys are going to have to go through scrutineering on your high voltage and your low voltage systems. All right, so there's two main electrical systems on there, which is your high voltage propulsion and your low voltage, which is basically safety kind of stuff, and or monitoring. Any of your telemetry stuff can be charged from that. The only place that we had in our car where the low voltage system was connected kinda to the high voltage system was on our contactor relays, which I did not see that on here, which needs to be addressed. Contactor relays. You have to have emergency shutoff buttons on your system, both for outside the car, so that people, in case that something happens and you're the driver, are out for some reason, that they can shut off both the power to the PV array and to the battery. We don't want any power, and it has to have buttons on the inside for both to shut both of those systems off as well. We used to have this giant button that the big red buttons that we did for that, and you can still use those, but they're required now to use contactor relays for this. The thing with the contactor relay, if you don't know, on the inside of them very easily is there's basically an electromagnet that occurs, and you have two low voltage terminals, which are the tiny ones on it, and then you have two larger terminals on it. The two larger ones go to your battery pack and are in line with your main power. They'll be heavy lines. Then you got two low ones on like that. I highly recommend, you're asking about the power, I highly recommend that you stay, we choose 12, but you definitely need to be 36 or below. And the reason being is because those two little wires are going to go to a button inside the driver compartment. And you're not allowed to have high voltage above 36 inside the driver compartment. So it only takes 12. And that line is actually going to go through your auxiliary battery. Because all it does is turn the switch. When I flip that, all it does is when I turn the switch on my car, it flips that little thing on the magnet, and that then activates opens up the line for the high voltage to go through. So when I said they're completely separate, that's kind of the one area where they're not. The other area would be maybe shunts. It's kind of like, you can argue that it's kind of connected, but not really. Shunts are another item. I mentioned the fuses. You are required to have a fuse that is rated for your system. You notice I didn't give you a particular amperage or anything. It has to be rated for your system at what you determine is going to be the peak on that. I told you before the 0909 motor ran 100 continuous and 300 amps peak. We never put a fuse in there. You're allowed to technically go like 125% above that. That's technically what you're allowed to do. We don't do that, and the reason being is 125 above puts me above 300 continuous on that motor, and I don't want to burn my motor up. I have no business pulling 300 amps anyway for that. I mean, if you do that, you guys are going to be poking at some point. You may be fine initially, but you're going to be running real slow later. So you don't do that. Keep in mind that you need to set that at what you determine is going to be your peak running. In your motor controllers, your motor may be capable of this, but you may in your motor controllers program it to where it only allows it to go this much right here because it may be the best system for you. So you have to have your main fuse in. It also has to be inside a, what do they call that box now? The high voltage enclosure. So you've got your battery box enclosure, and then you have, it used to be you came out and within 15 centimeters you had to be into a fuse, and it had to be covered. Now it's in an enclosure, and I read on the rules this year that it no longer, the high voltage enclosure, which includes your contactor relays and your fuses, needs to be in another box. That doesn't have to be any longer within 15 centimeters from the time it comes out of the battery box. It can be a little bit more. So you have a little more wiggle room in that, trying to manipulate that box around. However, don't have your fuse and stuff like that sticking out in the open or here like this, or things uncovered, because or that contactor relay, because somebody drops a wrench or something on that, you're going to have a major issue because it'll simply bypass that safety low voltage connector on it, and it will jump and arc across, and now you're dealing with that plus a large number of amps, which somebody's going to be lit up. So we don't want to do that. Questions, comments, concerns, complaints? Dr. Marks is going, we got to wrap this up.
Okay.